Hello, boys and girls. Welcome to Mrs. Vandu's Math Movies. This is lesson 2-6 for course 2, my 4th period class. In this, the title of this section is Fractions and Decimals, and our objectives are to convert between fractions and decimals. So we're going to take decimals and write them as fractions, fractions and write them as decimals. Okay, so first of all, we have a couple of definitions here about the types of decimals that we could get. A terminating decimal, okay, is a decimal that ends or stops, or for a bigger word, terminates. Okay, so examples of terminating decimals might be 0.5, 0.23, 0.1012, and so on. Okay, something that stops though. There's no indication that it's going to keep going or repeating in any way, shape, or form. A repeating decimal is very much what it says. It is a decimal in which the same block or set of digits repeats without end. We use something called bar notation for these. Okay, and I'll give you a couple of examples. So you might on your calculator get a decimal where you see it's just a whole bunch of threes and it fills up the whole screen with threes. Okay, as this would be what we would classify as a repeating decimal. We would write that with bar notation as 0.3 with a bar over the 3 because of the 3 repeats over and over and over again. Okay, you might also have something like this. You might have 45.454545 and so on. Okay, with bar notation, what I do is I go back and I try to find where does the pattern start. I have a 4, then a 5, a 4, then a 5, a 4, then a 5. So that's going to be 0.45 repeating with a bar over both the 4 and the 5. You can have several digits that repeat like this, and what you want to do is find the beginning of the pattern, and find the end of the pattern, and the bar covers all the digits that are within the pattern. We will talk about several in class as well, but here are a couple of quick examples so you have an idea of the difference between a terminating decimal, which stops, and a repeating decimal, which never ends and it has a pattern. Okay, let's look at a few examples. It says the total amount of rainfall yesterday was reported as 1/4 of an inch. Write this fraction as a decimal. Okay, so again, we're going to go back to the definition of a fraction, and also that the fraction bar acts like a division sign. So we're going to take 1 and we're going to divide that by 4. If we're doing it by hand, we would have to add some zeros, so 1.00. 4 does not go into 1, but it goes into 10 twice. 4 times 2 is 8. I'll subtract. 10 minus 8 is 2. Then bring down my 0. 4 times 5 is 20. Subtract, my remainder is 0. So I'm finished. I'll end. So 0.4 equals 0.25. So the total amount of rainfall as a decimal is 25/100ths of an inch. Okay, so again, it's going back to things we have been practicing this year. and it's tying fractions and decimals together. We've worked with decimals, we've worked with fractions, now we're tying them together. Okay, number 2 is looking at writing a repeating decimal, okay? And they give us a couple of methods here, side by side. Write 7/15 as a decimal. So pencil and paper method would, again, go back to what we did up here, division. 7 divided by 15. So I'm going to need to add, in this case, the authors have already added several zeros for you. So you can do one at a time or add 2 or 3. If I'm actually working this by myself, I just do one at a time. Okay, so 15 goes into 70 4 times, and that's 60. 70 minus 60 is 10. Bring down the 0. 15 times 6 is 90. Write down the 90. Subtract, correct. Bring down another 0. And you're going to see you keep getting 90 and a remainder of 10. So it's a repeating 6. Notice that the 4 does not repeat, but the digit 6 repeats. So 7/15, and no matter how long I keep doing this, I'm still always going to get a remainder. So that's how I know I need to stop at some point. And I see a pattern up here of something repeating. So 7/15 is equal to 0.46 with a repeating 6. Okay, and everyone's favorite, if you do this on a calculator, if you take 7 divided by 15, you get 0.4666. You might get a 7 at the end if your calculator rounds, but that is a rounded digit, so again, we would still get 0.46 with a bar over the 6. We'll practice a few of these and look at how they'll appear on your calculator in class, so we'll have a little bit of time to chat about that and answer questions. Okay. Now, our next one is taking a decimal and writing it as a fraction in simplest form. Okay, so write 4.105 as a fraction in simplest form. So 0.105 or 105 thousandths is equal to this fraction, 105. Oops, sorry, I was going to try to make that a little bigger. There we go. 105 over 1,000. Now, that is a simple transformation or translation from a decimal to a fraction using place value knowledge. If you get confused with the name of your places, a nice little trick is if there are 3 digits on the top of a decimal that you're converting to the fraction, then you should have a 1 followed by 1, 2, 3, 1, 2, 3 zeros on the bottom. Okay, the 4, you really don't have to worry about it because it's still going to remain a 4. It's the whole number. Okay, so the whole thing is 4 and 105 1,000ths. Okay. Use the greatest common factor to write the fraction in simplest form. So, excuse me, for 105 and 1,000, the greatest common factor is 5. So, this is again, the 4 is still not going to change. 105 divided by 5 is 21. 1,000 divided by 5 is 200. So in simplest form, this is 4 and 21 200ths. Okay, and here is an application of where you might be able or might need to use this conversion of fractions into decimals. One thing I do want to caution you about, though, don't always automatically transform every fraction into a decimal just because you can, okay? There should be a reason for it. You need to be able to work with fractions as well. Okay, let's look at this. In a survey of next year's 7th grade students, 0.25 said they will come to school by bus. 5/24 said they will walk. 0.375 said they will come in a car. and 1/16 said they will ride their bicycles. Order the means of transportation from most used to least used. So that's greatest to least. And a lot of the things we looked at in the previous section, it was least to greatest. So this is different. Okay, since we have an assortment, we have 2 decimals and 2 fractions. Let's go ahead and convert the fractions to decimals. This is a case where that's probably going to be the most efficient and easiest thing to do. Okay, so rewrite the fractions as decimals. So remember, 5/24 means 5 divided by 24. I'm sure you can, when you put that in your calculator, you'll end up with 0.2083333. Okay, the 3's are going to repeat, so you put a bar over that. Okay. 1/16 is going to end up as 0.0625. Remember, that's 1 divided by 16. Okay, and then we can compare them. Okay. Sometimes I find it helpful to list my fractions, my decimals, so that I can actually kind of look at them one on top of the other. Oops, 0.625. Now, also a lot of people like to go ahead and add zeros so that all of them are the same length. At that point, a little trick is that you can actually sort of ignore the decimal point and see, okay, which one's the biggest number there? 3750 is the largest. Okay, so this is greater than the next largest, which is 2500, which is greater than 0.208, which is greater than 0.0625. Okay, that was just luck that I lined them up that way. It's usually not going to happen that way. Now, the means of transportation, because it asks us to order the means of transportation. In other words, how are you going to get there? Now that I have my numbers in order, I can go ahead and match them up. So 0.375 said they will come in a car. So the car comes first. That's the car. 0.25 in the bus. 0.028 are the walkers. And 0.0625 will use their bikes. Okay, so again, we need the numbers to answer the question, but the question asks for the means. In this term, means is what type of transportation will they use? Okay. All right, that's a run through the types of questions you need to be responsible for in this section. Go ahead and give the quick checks a try. Bring in any questions you might have, any difficulties you come across, and we'll go over them in class. Thank you and have a good day. Bye now.